Hello. Now we are going to discuss principle of virtual work. The principle of virtual work is a fundamental and concept in mechanics and physics that provides a powerful tool for analyzing the equilibrium and stability of mechanical systems. It's based on the idea that a system is in equilibrium if the virtual work done by the all forces is zero for any virtual displacement consists with the constraints of the system. Here is the explanation of the principle of virtual work. So generally we observe this principle of virtual work in spring pendulum and wall also. Suppose if you apply the force on wall, so some displacement, instantaneous displacement is there. So we can't measure that displacement. So that type of displacement we can call the virtual displacement. So virtual displacement is an infinitesimal small and very hypothetical displacement that system undergoes without violation of the constraints imposed on it. It's not a physical displacement that the system could naturally experience, but rather conceptual perturbation used for analysis. Equilibrium condition of virtual displacement. According to the virtual displacement uh, principle of virtual work, a system is in equilibrium when the total virtual work done by all forces acting on system is zero for any virtual displacement. In other words, the system's position is stable if there is no net tendency for it to move any direction when you subject to the small virtual displacement. Like we said just now, when we apply the force on wall, so it's not going to tend any direction, right? So there is a small virtual displacement, hypothetical displacement on wall at microscopic level. So we can't measure that displacement. Such type of displacement we can call virtual displacement of the system. Even though we are observing such type of displacement in spring pendulums also, many equilibrium systems also we can feel that type of conditions. So to imagine arbitrary instances changes in the position vector of the particles of the systems, like virtual displacement we can consider. An infinitesimal virtual displacement of ith particle of a system of n particles is denoted by the delta r. This displacement of position coordinates only does not involve the variation of the time. Therefore, delta Ri equal to delta Ri Q1, Q2, and so on Qk and so on Qn. Suppose the system is in equilibrium, then the total force on any particle is zero, F equal to zero, where uh, I is 1, 2, 3, and so on n. Then the virtual work of the force Fi in a virtual displacement will also be zero. W equal to force into displacement, right? So therefore, similarly, we can sum of virtual work of all particles must vanish. Therefore, work equal to force into displacement equal to zero. Hence, principle of virtual work states that the work done is zero in the case of an arbitrary virtual displacement of system from a position of equilibrium. So the total force on ith particle can be expressed as force equal to applied force into constant force. Sorry, applied force plus constant force, where this Fi superfixer and this one A is called applied force. So small Fi is the force of constraint. So then arrange this equation. Therefore, work equal to force into displacement. Then force you need to substitute applied force and constraint force. In virtual work, the forces of constraints is zero. The second term going to be zero. Therefore, so remaining term is W is equal to F into dr equal to zero. This is the principle of virtual work. This is very important concept in classical mechanics. So next we are going to use this principle of virtual work. Try to derive the D'Albert's principle by using this uh, virtual work. So in place of force, we can use Newton's second law. You will get the D'Albert principle. Okay. Thank you.